If f of n is equal to 3 to the power of n plus 1, show that f of n plus 2 minus 4 times f of n plus 1 plus 3 times f of n is equal to 0. So we're going to start off by figuring out what f of n plus 1 is. So what we want to do is add 1 to the n in this term. So f of n plus 1 is going to be 3 to the power of n plus 1 plus 1, and 1 plus 1 gives us 2, so we get 3 to the power of n plus 2. Then we're going to use one of our laws of indices to break this down into 3 to the power of n times 3 to the power of 2, and 3 squared is going to give us 9, and it's going to be 9 times 3 to the power of n. So the law that I used there was law number 1, which tells us that a to the power p multiplied by a to the power q gives us a to the power p plus q. So basically when you're multiplying powers with the same base, you add the powers. So to get from 3 to the power of n plus 2 to 3 to the power of n multiplied by 3 to the power of 2, I went backwards with this rule. So I broke down 3 to the power of n plus 2 to 3 to the power of n times 3 to the power of 2, because when we multiply powers with the same base, we add the powers. So I actually used this rule, but I worked backwards. So f of n plus 1 gives me 9 times 3 to the power of n. Next thing we're going to do is figure out what f of n plus 2 is. So just like we did before, we're going to add 2 on now to the n value in this term. So f of n plus 2 is going to be 3 to the power of n plus 2 plus 1, and 2 plus 1 gives me 3, so I get 3 to the power of n plus 3. And again, I'm going to break this down using law number 1 to get 3 to the power of n multiplied by 3 to the power of 3. And the reason I got that was 3 to the power of n multiplied by 3 to the power of 3 gives me 3 to the power of n plus 3. When I multiply powers with the same base, I add the powers. So again, I used this law, but I worked it backwards. Then 3 to the power of 3 gives me 27, and it's going to be 27 times 3 to the power of n. So f of n plus 2 gives me 27 times 3 to the power of n. So then I'm going to go back to this part of my question. F of n plus 2 minus 4 times f of n plus 1 plus 3 times f of n should be equal to 0. So I'm going to write that down here. F of n plus 2 minus 4 times f of n plus 1 plus 3 times f of n is equal to 0. Then all I really have to do is just substitute in the values that we got for each of our functions. So we got f of n plus 1 to be 9 times 3 to the power of n. So where I see f of n plus 1, I'm going to swap it for 9 times 3 to the power of n. And we got f of n plus 2 to be 27 times 3 to the power of n. So where I see f of n plus 2, I'm going to swap it for 27 times 3 to the power of n. And I know from my question that f of n is equal to 3 to the power of n plus 1. So where I see f of n, I'm going to swap that with 3 to the power of n plus 1. So f of n plus 2 became 27 times 3 to the power of n. I bring down the minus and the 4, and that's going to be multiplied by 9 times 3 to the power of n, because that's what we got f of n plus 1 to be in this step of the question. And then we're going to add on 3, and that's going to be multiplied by 3 to the power of n plus 1, because f of n in our question was 3 to the power of n plus 1. And that is all equal to 0. So this became this. The minus 4 came down and was multiplied by this, which we got from here. And the plus 3 was brought down and was multiplied by this, which we got from here, equal to 0. So now we just have to multiply out. And we're going to bring down the 27 times 3 to the power of n. That doesn't change. Minus 4 multiplied by 9 gives me minus 36. And this is still multiplied by 3 to the power of n. And then we are going to break up 3 to the power of n plus 1 to 3 to the power of n times 3 to the power of 1. Again, using law number 1 from indices and working backwards. So 3 to the power of n multiplied by 3 to the power of 1 would give us 3 to the power of n plus 1, because when we multiply powers with the same base, we add the powers. So we work backwards, and 3 to the power of n plus 1 breaks down to 3 to the power of n times 3 to the power of 1. Then in our next step, we just bring down the 27 times 3 to the power of n, and we bring down the minus 36 times 3 to the power of n, and then we say 3 multiplied by 3 gives us 9, and this is multiplied by 3 to the power of n. And all of this is equal to 0. So then I notice that I have 3 to the power of n common to each term. So I can take that out as my highest common factor. So 3n divides into 27 times 3 to the power of n, leaving us with 27. 3 to the power of n divides into minus 36 times 3 to the power of n, leaving us with minus 36. And 3 to the power of n divides into 9 times 3 to the power of n, leaving us with 9. 27, take away 36, plus 9 gives us 0. And 3 to the power of n multiplied by 0 gives us 0. So we've shown that f of n plus 2 minus 4 times f of n plus 1 plus 3 times f of n is equal to 0.